Hello, we are discussing about GATE 1992 ECE paper and the topic we are discussing is electronic devices. This is second 5-mark question came in GATE. Look at the diagram. The diagram consisting of a MOSFET. The N-channel MOSFET with threshold voltage of 2 volts is used in the circuit. Initially the transistor is off and is in steady state. At time t is equal to 0, a step voltage of 4 volts magnitude is applied to the input so that MOSFET turns on instantaneously. Draw the equivalent circuit and calculate the time taken to output voltage V0 to fall to 5 volts. The device constants of the MOSFET are K is equal to 5 milliampere per volt square, RDS drain to source resistance infinite, CDS drain to source capacitance 0, CDG drain to gate capacitance is also 0. We need to calculate how much time does it requires to fall the output towards 5 volts. Answer for this question is 138 nanoseconds. We see how to solve this problem. This is the circuit diagram given and it is N-channel MOSFET. Initially N-channel MOSFET is in the off condition and it has reached the steady state. Whenever it is off, whenever the transistor is off, at that time 10 volts is supplying current. That current is going to be flowing through capacitor. Whenever current flows through the capacitor, capacitor gets charged and capacitor has reached the maximum of 10 volts. So the output voltage V0 as it is indicated, that will be equal to 10 volts, and under steady state capacitor act as open circuit. So for t less than 0, the MOSFET is in off condition and output voltage of the MOSFET, that is V0, is at 10 volts. Since under steady state capacitor act as open circuit, it has charged to the maximum extent, that is nothing but 10 volts. So we can write a statement like this. Initially MOS is in the off condition, so capacitor charges to 10 volts. Under steady state, capacitor charges the maximum value, so that V0 is nothing but voltage across capacitor, which is nothing but 10 volts. At t is equal to 0, 4 volts input voltage is applied, and whenever it is going to be applying, that is for t greater than 0, 4 volts is continuously we are applying. So the transistor comes into on condition instantaneously. Transistor coming into on condition instantaneously is nothing but transistor enters the saturation region immediately, and we should consider the condition for the saturation region such that it is in the on condition. So condition for saturation is VDS should be greater than or equal to VGS minus VT. This is a condition for saturation region of MOSFET. VDS drain to source voltage, which is nothing but V0 from this diagram. So V0 should be greater than or equal to VGS. We are applying 4 volts input, so 4 minus threshold voltage given as 2 volts. So V0 should be greater than or equal to 2 volts. So to maintain the transistor in on condition, it must be in saturation such that the output voltage can be at least of 2 volts. So the output voltage may be greater than or equal to 2 volts. The minimum voltage is nothing but 2 volts. So the meaning of this one, whenever the transistor is in the off condition, the output voltage is 10 volts. As it comes into on condition, it is reducing towards 2 volts, and output voltage is getting reduced from 10 to 2 volts. Whenever it is changing from 10 to 2 volts, getting reduced, by that time definitely it reaches a 5 volts in between. So how much time does it takes to reach from 10 to 5 volts? That is what we are going to calculate. The time required for the output to reach 5 volts from 10 volts. That is the indication. So when transistor comes into on state, VDS is reducing from 10 to 2 volts. But we need to calculate the time required to calculate for the output V0 to fall towards 5 volts. So what you should calculate is nothing but you should get an equation that is going to be giving at any point of time you can calculate the output voltage. So V0 equation at any point at any time, you must get an equation. How to get that equation we will see now. So look at this diagram. This is the given diagram. Whenever the transistor is in on condition, at that time current flowing through this one is nothing but drain current. The drain current is indicating it as ID, and current coming from the 10 volts battery is I, and current flowing through this capacitor is IC. So I is equal to ID plus IC. Okay, these are the current directions as indicated. I is equal to ID plus IC. Since the transistor is on for the t greater than 0, as we are applying 4 volts input. So from this one we can write I is nothing but 10 minus V0 divided by R. So at any point of time we are going with, so that we are writing it as V0 of t is equal to ID plus IC is nothing but C into dV0 by dt plus CV0 C into dV0 by dt. As the current flowing through this one, so this is maximum, this is minimum. Voltage drop is nothing but V0 minus 0, that is d of V0 of t by dt. Now you can write ID is equal to 10 minus V0 of t minus C into dV0 by dt. Okay, so what is meant by this ID? Current flowing through this transistor, drain current flowing through this transistor whenever it is in saturation. But we know the equation for the current whenever it is in saturation, that is ID is equal to K into VGS minus VT whole square. So we know saturation current equation for MOSFET, that is K into VGS minus VT whole square, and K value is given as 5 milliampere per volt square, VGS is given 4, VT is given as 2. So this is going to be giving rise to drain current of 20 milliamperes. So you can substitute drain current in the above equation. By that time, this can be written as 10 minus V0 of t by 5k minus C value is given as 100 picofarad. So 100 picofarad into dV0 by dt is equal to 20 milliamperes. So now look at this equation. Is this equation resembles first order equation or not? First order equation in terms of V0 of t. So solve this first order differential equation for V0 of t with initial conditions of Vc of 0 minus is equal to Vc of 0 plus is equal to 10 volts, because the capacitor voltage at t is equal to 0 is 10 volts. Capacitor doesn't change instantaneously, so that Vc of 0 minus is equal to Vc of 0 plus, that is equal to 10 volts. Using this one, solve the above differential equation. By that time we can get V0 of t is equal to 20 into 10 power 7 into e power minus t. So this is the equation for the output voltage at any instant of time. So depending on the t, you can substitute the t value and you will get the output voltage. So we are going with, let us assume at time t the output voltage is going to be 5 volts. Output voltage is dropping from 10 volts and it is reaching the 5 volts at this point. So to get the value of t at 5 volts, V0 of t replaced with 5 is equal to 20 into 10 power 7 into e power minus t. So t is equal to 138 nanoseconds. This is what the time required to reach the output coming from 10 to 5 volts. So the right answer for this question is 138 nanoseconds. Thank you.